In this session, we will take a look at the potential issues when running Dante audio multicast and SVSI network AV on the same VLAN and ways to mitigate any possible conflicts. Previously in the SVSI design class, we mentioned the possible IP addressing space conflicts that may result and suggested that the path of least resistance was to put each of the Dante and SVSI multicast traffic on separate VLANs to resolve any of these issues. However, with the advent of AES-67 support in SVSI and BSS audio hardware and the interoperability opportunities this presents, separate VLANs are really no longer a feasible solution, and both Dante and SVSI multicast traffic must be on the same VLAN. Note that the same conflict still exists with Dante multicast and SVSI multicast traffic. Let's take a little closer look at the process of creating multicast flows in Dante controller and the network traffic that results. In the situation where the same flow needs to be sent to a number of sinks simultaneously, the fan-out notice will be presented in the application, at which point multicast flows can then be created. Once assigned and routed, the multicast traffic will be forwarded to the subscribing receivers. Note that the IP address for the Dante multicast flows will be in the same 239.255 IP addressing space that is used for SVSI networked AV traffic. The destination port is 4321 for this traffic. It is this conflict, this IP addressing conflict 239.255, that needs to be resolved. Or avoided is actually the end result. Now, what if we add some SVSI AES-67 receiving endpoints, in this case, the N2422A 4K6444 receivers? In order to propagate the audio from the Dante transmitter to the SVSI receivers, we need to create AES-67 flows in Dante controller, which by definition will be multicast streams. It's the same dialog we saw before, except we enable the AES-67 flow with a simple checkbox. Once established, the audio will be available across the network in the multicast address space of 239.69. Here we see the created flow at 239.69.69.116 on port 5001. By virtue of the second octet not being 255, the AES-67 streams are not in conflict with the SVSI network AV traffic. FYI, that second octet is configurable in software with .69 being the default, and we would suggest that you use that default value as a best practice. But what if we need to route that same flow to the SVSI receivers and at the same time a rack full of crown amplifiers that support AES-67 and Dante? Even though we specified AES-67 in the multicast flow creation dialog, the traffic to the crown amps will default to multicast flows. Yes, there is actually double the network traffic than would appear at first glance. This may have ramifications if you are approaching saturation. So, being cognizant of this effect is important. This is the expected behavior of Dante supporting hardware. The Dante multicast will always be the preferred transport over any transport options, such as AES-67. So what's the problem? The Dante controller assigns multicast addresses randomly. We have no possibility of directly assigning IP addresses or through any sort of configuration. It's all a process that's hidden to us. It's a bit of a black box. When we're assigning AES-67 flows, that address, that assignable address, is actually viewable in Dante controller, as we saw. It's going to be in that 239.69.default addressing space being transmitted or propagated on port 5001. There is no conflict with AES-67 and SVSI network multicast traffic. However, when we're dealing with Dante flows, The issue is that that address is not viewable in Dante controller. There is no way of, from the application, of identifying what IP addresses have been assigned. And it is going to be on that, in that same 239.255 addressing space that SVSI traffic uses. And there are no configuration options. So the question is, how do we identify Dante multicast addresses on the network so that we, when it comes time to configure the SVSI hardware, which is a pure manual methodology, we can avoid any conflicts? Well, after creating the Dante AES67 multicast flows as needed in Dante controller, we need to access the switch to set up port mirroring. Port mirroring is used on a network switch to send a copy of network packets on one switch port or an entire VLAN to a network monitoring connection on another switch. Note that it will make this mirrored port essentially useless for anything but monitoring the other ports packets. On a Cisco SG, as we see here, the destination port is where the monitoring computer will be connected, and the source port is where the Dante multicast is originating. For other brands of switches, the nomenclature will change, the syntax will change. You'll have to refer to the documentation for each manufacturer to determine exactly how to set up port mirroring, but it's going to be a really rare case on a managed switch where it will not be affected, especially on a managed switch that supports the feature sets that we need with regards to SVSI multicast. And the other note is that this process will need to be repeated for each Dante device that is transmitting multicast flows. Or you could certainly do a VLAN to a single port, but depending on what sort of traffic you've got on there, you do need to pay attention to bandwidth and not exceed that 1 gig available on an access port. Once the port mirroring is established at the switch and the monitoring laptop is connected to the destination port, we'll bring up Wireshark and use Wireshark to capture and analyze the network traffic. The key here is to filter for UDP traffic with a destination of port of 4321, and that's what the filter looks like in the filter dialog. Once we've got that filter established, we can then identify the multicast IP addresses Dante controller has assigned to each flow. These IP addresses would then be entered into a blacklist that would be referenced when assigning stream numbers to the SVSI encoders, of course avoiding any of the Dante flow multicast IPs so there are no addressing conflicts in the system. So in review, first off, we would need to create all of our required Dante and or AES67 multicast flows depending upon the system requirements. We would then need to set up a port mirror at each and every Dante flow originating port, the source interface. We would then run Wireshark on the mirrored port or the destination port from the SGSI port mirroring configuration that we saw. We would then need to filter in Wireshark for that UDP destination port of 4321. And the syntax there is udp.dst port = 4321. Document the multicast IP addresses as shown, and we are targeting that 239.255 addressing space because that's the addressing space that's going to be in conflict with SVSI. And then finally, anecdotally, you are probably going to want to repeat this process after any Dante system reconfiguration, as there is a chance you may end up with a new set of IP addresses assigned to those multicast flows.